I recently posted a video about how agile project management is inappropriate for making big rockets. So what kind of project management is appropriate for making big rockets, and why is it more appropriate? If you've ever played around with Microsoft Project or Gantt Project or Project Libre, the latter two being open source project management software, you may have created what Microsoft calls a network diagram and what other people call a critical path method chart or CPM chart. You might be aware that you don't see these kinds of charts in agile project management software, except for the ones that have bloated to encompass numerous project management features badly. CPM charts enable you to keep track of task dependencies. Most agile projects don't need to plan for task dependencies because software mostly can and should be automatically module tested and then put through a CI/CD pipeline so that you're never in integration mode. This style of software development minimizes the impact of any dependencies that there might be in your software. You can't do that with a rocket. So let's take a look, an optimistic look, at Starship. Let's assume the next test flight puts a Starship in orbit. Yay! Now we can start working on reusability because Starship ain't going nowhere except low Earth orbit without reusability. What are the acceptance criteria for reusability for that milestone in the Starship project? The heat shield has to work without needing repairs. The engines have to sustain minimal damage and be reusable without repairing or replacing them. That includes the booster's engines, and that milestone hasn't been reached yet either, despite the booster having a far lower temperature re-entry than the upper stage. The reusability has to be far better than that of Falcon 9. Falcon 9 rockets are refurbished between launches. That means the launch cadence of a particular Falcon 9 booster can't be more than once every 2 or 3 weeks. That won't do it for Starship, as we will see. Once the spacecraft and their engines all come back in working order, you can then try for the next milestone, which is refueling in orbit. Why do we need rapid reusability before we can try refueling in orbit? Because otherwise SpaceX would need to build, stack, and launch at least a dozen Starships to carry enough fuel to orbit to refuel a Starship waiting to be refueled, and that assumes Starship will meet its extremely ambitious payload goals. Another dependency that could take multiple test flights to attain. Then, in order to want to fly a manned mission, like putting people on the moon, Starship has to be human-rated. And that means that the whole system has to hit a much higher spec for reliability. This is both for safety and so as to not require humans to wait in orbit for weeks or months for their Starship to get refueled. Download one of these open source project management systems I described earlier, start decomposing each of these major milestones into individual tasks, and make a critical path method chart describing the rest of the Starship project. You'll find that the project goes on for years with multiple large risks to overcome before a human flies anywhere on a Starship. There are thousands of reasons for this, but a big one is that reusability is both a positive attribute and a liability to the Starship project. Without achieving rapid reusability relatively early in the project, it's going to be a very long and slow grind to get to where the benefits of rapid reusability are realized, if ever. This all means that the riskiest part of the Starship project hasn't even begun.